Okay, in section 7.3, we're going to start looking at logarithms, and logarithms are the inverse functions of exponentials. So if we look at the exponential form from yesterday, we have y equals b to the x, just leaving the a off for right now, trying to simplify this, where you're just multiplying by a number again and again and again and again. Okay. Well, the logarithm form of this exponential would be log base b of y equals x. Okay. This is the inverse of an exponential. And initially, you just have to get used to seeing this format. And probably the best way to get used to this format is remembering the acronym BAP, base answer power. Okay, because on here, the little subscript is your base. The value that you're taking the log of is represents your answer, and what the log is equal to is actually your power. And that's probably the most important thing, is that you understand that a log equals a power. A log is a power. Okay? That's what a log is equal to. A log is a power. Okay? So we'll be doing a lot of work with that. So let's first start off by looking at the graph of an exponential, and then we'll look at finding the inverse, which is the log. So here, let's make a chart of values here. Here's our x. This is going to be 10 to the x power, and then this will be our y value. And let's use 2, 1, 0, -1, and -2. So we've got 10 squared. We know that's 100. We've got 10 to the first. We know that's 10. 10 to the 0. Anything to the 0 is 1. 10 to the -1 gets you 1 over 10, or 0.1. And then 10 to the -2, we know that's 1 over 10 squared, or 1 over 100, which is the same as 0.01. Okay. So we were to graph that. At -2, we're extremely close to 0. At -1, we're still extremely close to 0. At 0, we're at 1. At 1, we're at 10, which is all the way here. And then at 2, we're at 100, which is way off the graph. So you can see that this here skyrockets way off of this graph very, very quickly. Okay, so that's the exponential with a base of 10. Okay? So now what we're going to do is we're going to look at finding the inverse. So remember, to find an inverse, the first step of finding an inverse is going to switch x and y. So if we want to find the inverse, this is going to be 10 to the y equals x. And then the next step of finding an inverse is getting y by itself. Now the question is, how do you get y out of the power? Okay. Well, to get y out of the power, that would be what a log is. A log is a power. So if we want to get y out of the being an exponent, we let it equal to a log. So we're going to switch forms. Okay. So again, with your log, when you go to write log form, it's log base answer power. Okay. So we go to write it here. We're going to have log your base, which in this case is 10, your answer, which is x, equals your power, which is y. Again, this is base, answer, power. So your inverse here, this is your inverse. This is the inverse. Okay? And because our base here is 10, a log with a base 10 is called a common log. Okay? Common log. And if you have a log with a base 10, it's assumed to be base 10. So you could actually write that in this form. So you don't need to write the base. So here, if no base is written, assume base 10. Okay? And on your calculator, the log button on your calculator, if we look at your calculator here, the log button on the calculator here, you will notice, see how this is log right here? Well, right above it is 10 to the x. There's the log, the inverse is 10 to the x. So the inverse of log is an exponent, and if you have a log, it's base 10. So the button on your calculator is base 10. Okay. So now let's make a similar chart up. Okay. And if this is truly the inverse, then what we should be able to do is we should be able to take the y values here and let those be our new x values. So our x's are going to be 100, 10, 1, 0.1, and 0.01. Those are going to be our x values. Our inverse function, we know, is log of x. You could put the base 10 in there if you'd like. It's assumed to be base 10. And let's find out what our y values are. Okay, now an inverse function should take these x values and turn them back into the original values that we had here. Okay, so let's see. So let's do log of 100. So we can do that right on our calculator. So on your calculator, let's clear that out. Let's do log of 100, hit enter, and you get 2. If we do log of 10, what do we get? You get 1. If we do log of 1, what do we get? You get 0. Oops, let me write this out. This is log of 10 is 1, log of 1 is 0, log of 0.1, if we do that, log of 0.1, hit enter, that works out to be -1, and then log of 0.01, that works out to be -2. It was log of 0.01. Okay, so you'll notice that the log of those values gets you right back to what we started with. Okay, so our original function was an exponential 10 to the x, and it took a 2 and turned it into 100. Well, the inverse function of that is log of x, and that takes 100 and changes it back into a 2. Okay, so those are inverse functions. Okay, and we're going to get practice today going back and forth on going from log to exponential and exponentials to logs.